All right, so here we go again. Geometric Foundations 3.2. All right, so we nailed 3.1 the other day, so now it's 3.2. We've measured segments. Now it's time to measure some angles. So as we look at this one, so we are going to look at measuring angles. So first of all, what the heck am we talking about with an angle? Well, we've seen angles before, and you look at these, and they've got this situation, looks like this right here. The angle, and we're going to measure this in here. So a couple things we need to be aware of. Realize that when we look at an angle, we're talking about this space in here. We measure it as far as this degree distance in here. So remember, we measure angles in degrees, not anything big that you haven't seen before. We're going to kind of look at it. If we're looking at an angle symbol, say we're saying the measure of angle 2, we do M for measure, we would show there's the angle symbol, measure of angle 2. Or if we're just talking about angle 3, we're going to use that. Now, the way that we name an angle, we use 3 points, much like we do with a plane. So if we're looking at this one and this one, let's put 3 points here. Let's call this one A, C, G. So as you look at this, we would call this angle A, C, G, or we can call this angle G, C, A. Notice it doesn't really make a difference which one my endpoints are, which ones I start on. Doesn't make a difference which one I start with. The angle is just the same whether we start this way and draw it, or whether I come back and go the other way and draw it. Okay, the important part is this center one. This has to be this point right here. Anybody know what that's called? Yep, that's it. It's the vertex. So we look at that. So that is the vertex. When we name it, the vertex has to be this right here. So that's what we're talking about. Okay, so enough of that real quick stuff. Let's go in here and let's take care of it. So an angle, it's 2 rays. When we look at an angle, it's 2 rays with a common endpoint. It's 2 rays with a common endpoint. So it's made up of 2 rays that go with. So here's our endpoint. So I've got one ray right here. We'll call this ray AD. And then we have another ray that goes like this, and we'll call this ray AR. So in this case here, we're looking up, it's ray AR and ray AD. So together, those 2 rays make an angle. 2 rays with a common endpoint. So we name them. We name it by its vertex. Okay, we name it by its vertex. So an example of this one down here, we name it. We may call this angle A. We could call it angle A. Okay. So there's one way we can name it. We can name it, and if there's only one angle, we can do it there. We can name it by its vertex. Now, another way we can name it is name it by an angle, by a number. So let's just put a number in here. We'll call this 2, I think is what we did on the other page. So we might call this angle 2. Notice we've got the angle symbol in here in between the 2 rays. That's how we know we're talking about the name of this angle. Or the last thing is by a point on each ray in the vertex. So just like we talked about before, a point on each ray and the vertex. The vertex has to be in the middle. So we could also call this angle RAD, angle rad. So this is an awesome angle right here. So here we go. So 3 ways that we can name an angle. We name it by its vertex. We name an angle by its vertex. Okay, and that works if we have just a single angle by itself, located by itself. It doesn't work if we have some sort of combination or multiple angles coming off the same vertex. We can name it by a number inside of the angle, or we can name it by 3 points, 2 points on 1 point on each ray and the vertex. So there's where we are on this. So looking at this, this is where we are. All right, so let's move up here and let's look at a couple of them. So we've got this angle. Now, measure of angle DOG, angle DOG. If we look at that, what is the measure of angle DOG? Well, we look at right here, and that says that it is 52 degrees, okay? If we look at it right there, it's 52 degrees. So what are we talking about? Angle DOG here. could also be, could be equal to, when we look at that, it would be, if we're talking about this one, we're looking at, and notice we talked, sorry, let me slow down, guys. We talked about congruent before, okay? So we can say angle DOG is equal to angle O. Why? Because they're exact same thing. Remember we talked yesterday about congruent and equal. If we're talking about the exact same thing, they can be equal. So angle DOG is equal to angle O because they're the exact same thing. The measure of those angles is 52 degrees. All right? Now, let's look down here at this one. The measure of angle A is 70 degrees. The measure of BCA is 70 degrees. So these two angles are 70 degrees, and that doesn't work too well. Can't really see those. Let's try something a little bit easier here. So let's say that this is 70 degrees, and this angle is 70 degrees. Now what we can say then is that these two angles, and I'm going to renumber angle, these two angles are congruent to each other. They're equal in measure, okay? Angle A and angle C, or angle 1 and angle 2, they are congruent to each other. They're not equal. Now their numbers are equal. Their measure is equal. So we look at that. Now, we'll look at measuring with a protractor. That's one you should have already done. But if you've got questions about measuring this thing with a protractor, that's one, come and see me. We need to sit down and we need to talk, and let's make sure that you can use a protractor. I'm going to operate under the idea that you have that you understand what that means. But if you don't know how to measure an angle or measure a triangle or any sort of angle with a protractor, come and see me. This is your responsibility. Now look at angles. Classifying angles. We can classify angles as acute. That means less than 90 degrees. So an acute angle is an angle that's less than 90 degrees. A right angle is equal to 90 degrees. Equal to 90 degrees. An obtuse angle is greater than 90 degrees. Greater than 90 degrees. And a straight angle is 180 degrees. Okay? And I'm sure some of you go, a straight angle, what are you talking about? Well, that's what happens when we have two rays that go in opposite directions. So we have one ray that goes this way, the other ray goes in this opposite direction. This angle, okay, we still have a ray. Okay, we still have two rays. Those rays just happen to form a line. It's called a straight angle, and its measure is 180 degrees. All right, so here we go now. Time to get into the fun stuff. The fun. So when we look at these, let's go ahead and let's tackle some. So using this diagram to answer the following questions. It says angle CBJ. So find over here. CBJ. Angle CBJ. That means we're looking at this angle right here. The one that has these two symbols right here. And those are congruent symbols. Is congruent to, so which other one matches up with that one? Notice here over here, this one has two congruent symbols. So what do we call that? Well, we need to name that. We can't name it just by its vertex. We can't say angle H because angle H has 1, 2, 3, 4 angle H's. That's not going to work. So we need 3 points with a vertex in the middle. So we'll use D, H, G. So angle D, H, G. And yes, you're going to need this diagram. It's not going to make any sense if you don't get this diagram. So you may want to hit pause, copy this diagram in your notes. All right, so now look, angle FJH. So we start at F, we go to J and go to H. Notice here, 1, 2, this one has 3 marks here. So find another one that has 3 marks. Hey, there it is right there. So which angle? Well, there's our vertex. So let's see, this angle, A, there's 1 point, so it's B, J, A. So it's congruent to angle B, J, A. I think I need to get a skinnier pen on this one. The point is almost too fat. Okay, so angle BJA. So angle FJH is congruent to angle BJA. All right, now listen to the next statement. If the measure of angle EFD, let's find EFD. EFD, hey, that's this angle right here. The measure of this angle equals 75. then the measure of angle JAB has to equal, well, let's look. One congruent mark there, one congruent mark here. Hey, they're equivalent to each other. So the measure of angle JAB has to be 75. So we're looking at that one. So 75 degrees, and I left off degree symbols there. 75 degrees as well. All right, let's look at this one. The measure of angle GHF. Find GHF. Hey, that's one we already found. If that's 130, then the measure of angle JBC, two congruent angles, it has to be the same, so it has to be 130 degrees. All right, so hopefully you're starting to see that congruence means equal in measure. So you've got to look at those and look at those congruent marks. We use these congruent marks to show which angles are congruent to each other. So as we find them, that's where we're going to use. All right, so let's look at this next term. Angle bisector. You know, we talked about segment bisector yesterday and looked at a segment bisector. Well, an angle bisector is a segment, ray, or line that divides an angle in two. So if we look at it, if we have, say we have an angle here, and there's K. So here's an angle right here. If KE is an angle bisector, so that means KE here, if KE is an angle bisector, what does that do? Well, it splits this big angle into equal parts. That means that this, see if I can get this angle here is congruent to this angle here. Those two angles are congruent to each other. They are equal in measure. So we look at that. All right. So let's look at this kind of real quick and find what we've got here. So we're going to find X. It says that AT is the angle bisector of MAH. Okay, so if it's the angle bisector, we know that it bisects, cuts in half. So this part is equal, congruent to this part. So if the measure of angle TAH equals 4x plus 20. 4x plus 20. Okay, so if we know that, then that means that the measure of angle MAT has to be 4x plus 20, right? They have to be equivalent to each other. So when we look at them, they both have to be equal. So let me just throw something out there first to solve. What if I tell you that the measure of angle MAT, what if I tell you the measure of angle MAT is 80 degrees? Can we find X? Well, hopefully so. We set them equal to each other because 4x plus 20 is equal to 80. Those two have to be equal to each other because they're congruent. So let's go ahead and solve this. We're going to subtract 20 from both sides. We get 4x equals 60. Now what do? We divide by 4. And we find that x equals 15. X equals 15. So there we go. We found that one right there. So looking at this one. All right, so let's take a look at the next one over here. So we've got angle LOV. LOV is congruent to angle VOE. So this angle, congruent to this angle. We always want to make sure we put those congruent marks and make life easier on us. And I tell you that the measure of angle LOV equals 7x minus 14. Okay? So, and let's say, what if I tell you that the measure of angle VOE is, let's go easy. Let's go 16, Josh?
60.
60. Oh, no, it can't be 60 because the two of them together don't add up that much. Let's go with this angle equals 30 degrees. Okay, so here's what I want you to do. Hit pause. VOE here, this angle is 30 degrees. So you're going to hit pause. Go ahead and try to work it yourself. Come back to me as soon as you think you got it. All right, so here you go. Welcome back. Hopefully this is what you've got. You've got it solved. And x is either 6 2/7 or approximately 6.29. So there it is. Now, notice the last question. What's the measure of angle LOV? LOV, well, LOV, that's congruent to VOE. So if VOE is 30, what's the measure of angle LOV? It has to be 30 degrees as well, since those two are congruent. All right, well, this wraps it up. Hope this helps you. I will see you in class tomorrow. Good luck. Have a great evening.